AI and machine learning have recently become two buzzwords, and people often refer to them interchangeably, but that's not quite accurate. Artificial intelligence is the branch of computer science that attempts to build models capable somehow of behaving intelligently, while instead machine learning is the science of getting computers to perform certain tasks without being explicitly programmed. In this video today, we'll try to provide an example, two examples in fact, of how you can use machine learning to identify successful strategies, and these are just examples. Before we do that, let's look at what machine learning is capable of doing. Machine learning can perform two different types of tasks: unsupervised learning and supervised learning. Unsupervised learning is typically done when you have a bunch of data and you don't know what are the relationships within your data, i.e. the data is not very well organized. The type of models that are typically used within unsupervised learning are clustering algorithms. An example, for instance, could be a telecom company that needs to install some towers to enhance the signals in a certain area. And clearly, deciding where to put the towers is a result of an optimization. But unsupervised learning can help you do that. You just need to collect data about the population, where they are located, where the people are located, and some additional attributes like what kind of services they need, how much data they want to use, and so on and so forth. Once you've done that, you can pass the data to a clustering algo, and as outcome, what you will get are geographical areas are going to be assigned to a specific cluster, and within each cluster then, the telecom company can go and install a tower. Supervised learning, like the name says, is when instead your data is already well organized and you do have input and output relationship that you can use. So then the models in this area are there really to learn the relationship between input and output. There are two types of models that you can use: classification and regression. Classification is typically used in object classifications. For instance, let's imagine you have 1,000 pictures of a telephone, and you can ask a model to learn those pictures, so the next time that a picture contains a telephone, the model will be able to identify that. And then regression instead is when you need to predict really continuous values. Imagine when you need to predict handwriting, or you need to predict or classify handwriting in this case, or you need to predict the weather forecast or a stock prediction. The way it works is you have a set of inputs, you have a set of outputs based on historical data, and you're asking the model to predict. Not everything is predictable, obviously. You need to have, you really need to train a model with the real inputs that are affecting the output. If you don't have that, the model will be able to learn something, but that will lead to inconsistent results. So the application, there are two examples that we would like to cover in this video. The first one is there to, we're trying to understand if there is any predictive power in the daily historical returns of a stock. So as example, we've taken Barclays. On the left-hand side, you can see the price chart, and on the right-hand side, instead, you see the daily returns. Obviously, from the right-hand side, it's impossible to answer the question if there is any predictive power or not. The first thing to do is we need to dive into the time series and understand and look at a small sample. So let's focus, for instance, between the 8th of December 15 and 14th of December 15. So we've isolated 5 daily returns. The question here is there any predictive power? i.e., is it possible, given these 5 inputs, to predict what happened in the following day? If the answer is no, if there is no predictive power, then it means that the daily returns are simply randomly moving, and therefore you cannot use historical data to predict the future price. So how do we do this? To do this, you need to organize the data set. So we said that we are interested in taking the 5-day pattern. We need to collect the data in this way. So we take the sequence of daily returns, aggregate them into a 5-day pattern, and then we put them all together. So this is a small sample. In reality, for this example, we've taken 3,500 observations. Here you just have a smaller subset. Once you have that, you can pass the data to an algo and a clustering algo and derive the outcome, i.e. the clusters. The algo that we used is the k-means algo, which is very widely used in clustering. And we requested to get 6 clusters. You can also request the optimal number of clusters, but in this case we were interested to see 6 different clusters. The outcome of the algo is displayed here on the right-hand side. So these are the so-called centroids. These are the centers of the respective clusters. But also what you get out of the model, which is not displayed here, is a classification, i.e. you are able to get for each pattern where the pattern belongs to, which pattern belongs to which cluster historically. And so when you have that information, you are able to perform some very simple analysis. The investment strategy that we're trying to test here is to buy the share price of Barclays at the close and hold it for 1 day. And what we did, we basically constructed 6 portfolios. Each portfolio is invested after a cluster has occurred. So for instance, portfolio 1 will invest only after cluster 1 occurs. Portfolio 2 will invest only after cluster 2 occurs, and so on and so forth. And what you can see here on this in-sample data set, the in-sample because that's the one that we've used to cluster the universe, what you can see is that there are 3 clusters that perform remarkably well and 3 clusters that perform remarkably badly. So the 3 clusters that perform well are cluster 1, 3, and 5. So clearly this is an in-sample data set, so it tells us nothing about the predictability of Barclays share prices. But what we can do now is to apply these 3 clusters using the centroids as derived from the optimization really from this stage to some data sets of Barclays shares that the model has never seen before. So we have now prices going from December 15 till April 18. So these are nearly 3 years worth of data without having to retrain the model. So it's a very long data set. And what happens here is that clusters 1, 3, and 5 has in fact produced a very strong performance relative to the share price of Barclays. In fact, there was an outperformance of 83% in this period. Although it's not conclusive and it's just an example, what we can say is that using the historical 5-day pattern of daily returns, it was possible in this case, in the case of Barclays, to generate some value. The second example that we would like to examine today is based on candlestick charts. Candlestick charts, as you can see here on the left, for the case of Vodafone, is a way of displaying the range of how security is moving throughout the day. So in order to check if there is any specific return following a candlestick, we have to start collecting some attributes for the stock. So what we've done here is we've collected 4 distinctive attributes. We're looking at the full range, high over low. We're looking at the body of the candlestick, the close over the open. And then we are recording also the upper shadow and the lower shadow. Now we have all the attributes for all the candlesticks, and what we can now do is pass this data through a k-means algo like we did before, and ask the algo to tell us, to give us the 4 clusters that are best representing this time series. And the results are presented down here, so these are the centroids, and the outcome is actually quite intuitive. You have cluster 3, which is a very strong day when the market opens at 101, let's say, and closes 3% higher. Then you have cluster 4, which is another positive day, but not so strong. And then you have really 2 clusters, which are the copy, effectively, of cluster 3 and cluster 4, but where the situation is opposite, on the opposite side, i.e. the opening price is much higher than the closing price. So these are the 4 clusters that we got for Vodafone. Now what we can do, we could do exactly the same thing that we did earlier and go to test what is the return if you would invest after a certain cluster has occurred. And what you can see here in the in-sample results actually are quite interesting. You can see cluster 1 has been performing consistently good. And then you can see cluster 2 that towards the end of the period also started to performing well. Now let's go back. Cluster 1 and cluster 2 are the 2 red clusters. So that tells you that if you would buy Vodafone after a very bad day or a negative day, the probability to get a good rebound the following day is quite high. What happens instead if you buy Vodafone after a very strong day, cluster 3? Well, the results is the cluster 3 is the yellow line. It tells you that actually you would not be able to make any money at all. Again, this is in-sample data, therefore we cannot use it. We need to go and test the centroids onto a new data set, so on fresh data. In this case, we're taking data from December 13 till April 18. So the period is very long. It's nearly 5 years without having to re-optimize the model. And what you do see that if you consistently invest after cluster 1, so we've only taken one cluster, not cluster 1 and cluster 2, you can generate, or you would have generated, a very strong return, in this case an outperformance of roughly 50%, which towards the end of the period has not performed very well, indicating maybe that the model needs to be retuned. So how can we conclude? What we believe is artificial intelligence, but more in general machine learning, is incredibly powerful. You've seen two examples that were very fast to put together. It's clustering algorithms allow you really to organize your data set in a good way. But contrary to what we said at the beginning in the introduction, unsupervised learning is not really, we got a huge data set, we don't understand anything about the data set, we just put it through a model and then we get a successful trading strategy or a successful outcome. You still need to organize the data set in a way to get an answer to a problem that you have. In this case, the two problems that we try to resolve is there any predictive power in the last 5-day returns, or is there any predictive power in the shape of a candlestick? You can't just simply say, I take the returns of Vodafone, I throw it to the model, and then I'm going to get a successful strategy. So you need to be organized and you need to have an objective in mind. Finally, I think that it is very powerful. However, the models are very sensitive. Therefore, if you rerun the same example multiple times, you will get potentially different outcomes. So you really need to be careful. You need to train the model quite a lot in a very robust way if you plan to use it going forward. And finally, artificial intelligence has been around for many, many decades. Investors have moved away or didn't like it in the past because they are black boxes. You don't really understand what happens inside the box. So clearly, being able to reconstruct the outcome of any of these exercises is quite challenging, because the ability of machine learning is to identify relationships that human eyes are not able to identify. Therefore, you need to rely somehow on the model that you built. We are hoping that you found the video interesting, and we're planning to put other examples using the supervised learning in the near future. Thank you for your attention.